Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from definite integrals involving Signum function and the fractional part function, right? So here we have to find the value of this definite integral from -1 to 1, and the integrand is x signum of x divided by the fractional part of x plus 1, right? So let us find out the definition, the value of this integral using the definition of signum function and the fractional part function, right? So let us first call this integral as I. Now before proceeding further, let us first take the simple definition of signum function and the fractional part function, right? So first we will take the signum function. The signum of y is defined by signum of y is equal to +1 whenever y takes the positive values, right? Y is greater than 0, and signum of y takes the value 0 whenever y is equal to 0, and signum of y is -1 for all values of y which are less than 0, right? So this is the definition of signum function, and let us take the definition of the fractional part function. So the fractional part of x is defined as x minus greatest integer of x, right? So these two definitions will be used here to find out the value of this definite integral, right? And here we must note that the domain of this fractional part function is the set of all real numbers, right? So the domain is the set of all real numbers, but the range is from 0 to 1, right? It means the fractional part of x must lie between 0 and 1, right? So now let us proceed further. Now viewers, let us concentrate on the limits of integration. So here the lower limit is -1 and the upper limit is 1, right? So if we draw the number line here, and if we represent these 2 points over the number line, so we have here -1 and here we have 1, right? And between -1 and 1 we have the integer 0, right? And this integer 0 is going to play an important role while we evaluate this integral, right? Or in other words, we can also say that this point x is equal to 0, it acts as a breaking point, right? It acts as a breaking point to break this integral I as a sum of two integrals, right? So we'll write I is equal to I1 plus I2, right? So now I1 is from -1 to 0, right? Why we are breaking this integral I as a sum of two integrals, we'll understand it in a short while, but let us first write the value of I1. I1 is from -1 to 0, and we have x signum of x divided by the fractional part of x. Now we can replace this fractional part of x by x minus greatest integer of x, right? And here we have dx plus, and here we have, here we'll have the +1, right? And then we have the second integral that is from 0 to 1, and we have x signum of x, and here we have x minus greatest integer of x plus 1 dx, right? Okay. Now let us once again go back to the definition of signum function, right? So signum of y will take +1 value whenever y is greater than 0, right? And here if we take this part of the number line, that is from 0 to infinity, then we see that all the points which lies towards the right of x is equal to 0, they are all greater than 0, right? and the points which lies towards the left side of x equal to 0, that is towards this side, and here we have minus infinity, so all these points are less than 0, right? So here we see that we have signum of x, right? So signum of x will take the value -1, right? Because signum of x is equal to -1 when we take this interval, that is from -1 to 0, right? Because in this interval -1 to 0, all x are less than 0, and here when y is less than 0, signum of y takes the value -1, right? And similarly, signum of x will take the +1 value whenever y is greater than 0, and in this case we have x greater than 0, so when we take the interval from 0 to 1, right, from 0 to 1, then we have signum of x is equal to +1, right? So this value will be replaced by -1, and this value will be replaced by +1, right? Okay, now we have to take care of this greatest integer of x, right? And see, when we take this interval, that is from -1 to 0, so when x lies between -1 and 0, then by the definition of the elementary definition of greatest integer function, it says that the greatest integer of x is equal to -1, right? And when we take this interval, that is from 0 to 1, right, when we take 0 to 1, then this value, the greatest integer of x, will take the value 0, right? So this will be replaced by -1, and this greatest integer of x will be replaced by 0, right? So now we can rewrite these two integrals as -1 to 0, and we have x times -1. Here we have dx, and then we have x minus -1, and here we have +1, and then we have 0 to 1, and here we have x times +1, because signum of x is +1, and here we have x minus 0, and here we have +1, right? So now we have these two integrals. Let us rewrite these integrals as, see, here we have -x, we can take negative sign outside the integral, so we have x dx, and here we have x plus 2, right? Minus minus plus, so 1 plus 1 is 2, and here we have 0 to 1, and here we have simply x, and here we have x plus 1, right? So now here by this discussion we come to the conclusion that we have simplified this integral as a sum of two very simple integrals. So now let us separately calculate these two integrals. So I1 is minus 1 to 0. Here we have x plus 2 dx, right? So here we can make use of the method of substitution. So let us substitute, say z is equal to, or we can take u as x plus 2, right? So du is equal to dx, and when x is -1, then we have u is equal to -1 plus 2, so that is equal to 1, and when x is 0, u is equal to 0 plus 2, that is 2, right? So now I1 is minus, and here we have 1 to 2, and for x we can write from here u minus 2, right? So we have u minus 2, and here we have du, and for x plus 2 we can write u, right? So now we can rewrite this integral as 1 to 2, and we have 1 minus 2 over u, right? And the integral of 1 du is simply u, and the integral of 1 over u is the log of u, and the limits are from 1 to 2, and here we have the negative sign. So now let us find out the value of I1 by substituting the limits, and we'll take the difference. So we have minus, and we have 2 minus 2 log 2 and minus 1 minus 2 log 1, right? And the value of log 1 is 0, so this term is 0. So we have minus 2 log 2, and this is minus 1, right? Because this term is 0. So now we have minus 2 minus 1 is 1. So this is 1 minus 2 log of 2, and this can be written as 2 log 2 minus 1, right? So the value of I1 is equal to 2 log 2 minus 1. Now let us calculate the value of I2. So now I2 is equal to 0 to 1, and we have x dx divided by x plus 1, and now we can write this x as x plus 1 minus 1 over x plus 1. Here what we have done, we have added and subtracted 1 in the numerator, right? So 1 and 1 get cancelled, and we'll get the original integral. So we'll now break this integral from here, and we have 0 to 1, and we have x plus 1 over x plus 1 minus 1 over x plus 1, right? So now we can write it 0 to 1. These two terms get cancelled. We have 1 minus 1 over x plus 1, right? The integral of 1 dx is x, and the integral of 1 over x plus 1 is log of x plus 1, right? And the limits are from 0 to 1. So when we take 1, here we'll have 1 minus log of 1 plus 1 is 2, and when we have 0 here, we have 0 minus log of 0 plus 1 is 1, right? And now log 1 is 0, so this term disappears, and we left with 1 minus log of 2, right? So viewers, the value of I2 is 1 minus log of 2. So now to get the overall value of I, which is the sum of I1 and I2, so I1 is 2 log 2 minus 1, and I2 is 1 minus log of 2, and this one and this one get cancelled. We are left with 2 log 2 minus log of 2, and that is equal to log of 2, right? So viewers, the value of the given integral, which is in which the signum function and the fractional part function are involved, is equal to log of 2, and this is how we solve this integral.